5, we have to interpret a graph. And this comes under the topic of mathematical modelling. And so far we haven't had a question like this in the exams. So it would be interesting to see if some of these ideas come up. In part A, part 1, it says, state the number of hours that the diesel generator is required. So reading through the question, we see that the generator is used when the demand exceeds the supply. So looking at the graph, demand is the solid line and supply is the dashed line. And in between 800 hours and 1800 hours is when the solid black line is above the dashed line. So from 800 hours to 1800 hours would be 10 hours in total. In part 2, it says find the maximum rate at which the diesel generator should be able to generate electricity. Remember that power generation is itself a rate, so the amount in kilowatts is a rate. So all we are doing simply is seeing by how much the demand exceeds the supply. That's all it is. We can see the biggest difference is in that end part with the bigger gap. There's a demand of 1,200, a supply of 400, and simply the difference in between those two is 1,200 minus 400, 800 kilowatts. And that's all it is. Now in part C, we are given a graph of kilowatts over time. And it says to determine the total amount of energy used. So you have to have some understanding here of power being a rate, and then you would multiply that rate by time to get the energy that's produced. And that will be in kilowatt hours. And this, in fact, is the area underneath the graph. It's the total amount of energy used, so that is the demand. So we need the area underneath the unbroken black line. So it starts off from midnight through to 900 hours. So that's 9 hours at power of 100 kilowatts. So we do 100 times 9. Then the power goes up to 1000 kilowatts, and that's from 900 hours to 2100 hours. So that's for 12 hours. So we add on 1000 times 12. Finally, we have the 3 hours from 2100 hours to midnight. So we multiply 100 times 3 by 3. It's back to 100 kilowatts. And in total, we've got 13,200 kilowatt hours. Now, I don't know how much you need to learn yourself about kilowatt hours. Be aware this is a specimen paper, and they are to some extent trying to show what ideas they have for this course. However, I think it's a good question and certainly worth your time learning. In part 2, it's asking to find the minimum amount of energy that the system needs to store in order to meet the demand. The demand is when the demand is exceeding the supply. So one way to do this would be to find the energy used between the hours of 1200 hours and 2100 hours. Also find the energy supplied during that time period, and then find the difference of the two, and that's how much short they are of energy during that period, which would need to be saved in advance. However, there's maybe a slightly neater way of thinking about this is on the graph. It's actually that highlighted area which you can see is the difference between the area under the black line and the area under the dashed line, and that represents the difference. So along the vertical axis it's from 1000 to 200 kilowatts, so that's a gap of 800 kilowatts, and this is carrying on for 9 hours. So we simply do 800 times 9. So 800 times 9 is 7,200 kilowatt hours.